Hey there, all you Sioux High Earth Science students. Yep, this is Mr. McLeod again. Welcome to part 3 of our series of podcasts on the structure of the Earth and plate tectonics. Today, let's take a look at the connection between volcanoes and plate tectonics. So get your notebook out, something to write with, and let's erupt. Or let's quake. Or why don't we just, move on. This map shows the margins of the Pacific tectonic plate and surrounding region. The red dots show the location of almost all the volcanic activity along this plate boundary. Now, the activity along these plate boundaries is called volcanism, so write that down. Now, the majority of this volcanism, no, not like Star Trek character Spock, is focused in lines along the plate boundaries. For this region, this area is known as the Pacific Ring of Fire. You need to get that in your notes. But why are all the volcanoes located at the plate margins? Let's take a closer look. Volcanoes can be formed in 3 ways, and let's get them in your notes. First, they can occur via subduction. Write that down. You can see the word subduction right here on the slide. Recall from a previous podcast that the subducting slab dehydrates or gives off superheated water that forms new melted rock or magma that will rise through the crust to be erupted at the surface. Also get that in your notes. Next, volcanoes can occur via rifting. Yep, write that down, rifting. You can see rifting right here on the slide. In rifting, 2 plates pull apart, allowing molten magma to rise into the space created, producing volcanic eruptions at the surface. Write that down. So you can see here in this slide, this plate's going this way, this one's going that way, and the space it creates in here creates a rift. Lastly, volcanoes can occur at what are called hotspots. Write that down. Hotspots are volcanoes that do not necessarily occur along a plate boundary. So hotspot volcanoes can form in the middle of tectonic plates. Yep, get that in your notes. Okay, now let's take a look at hotspot volcanoes. Notice where hotspot volcanoes are located in comparison with the ones that occur along plate boundaries. A hotspot is a location on the Earth's surface that has experienced active volcanism for a long period of time. Write that down. Now, this is also where hot mantle plumes of magma explode above the surface in the middle of a tectonic plate. Also write that down. So you see that mantle plume right here. We're going to talk about that here in a second. And you can see now that this is where the melt or the magma's at. And this is now how it erupts to the surface. Now, hotspots are in the middle of volcanic plates. A mantle plume may rise at any location in the mantle, and this is why hotspot volcanoes are independent from tectonic plate boundaries. The Hawaiian island chains are an example of a hotspot volcano, and you can see now this on the right-hand slide is an example of a hotspot volcano that occurs in Hawaii. So make sure you get that in your notes as well. Hotspots commonly form volcanic island chains, like we said, the Hawaiian Islands. These result from the slow movement of a tectonic plate over a fixed hotspot. Write that down. A fixed hotspot, one that never moves. If this volcanic activity continues over time at a hotspot, this will create new islands as the plate moves the position of the old volcanic island from over the hotspot. Write that down. So now as this oceanic crust moves the direction of this arrow, each time a plume rises up, it forms now a new island. So we're moving from right to left here in this slide. Therefore, the youngest, most active volcanic islands are nearest the hotspot, and the oldest and extinct volcanoes become older and more eroded as they move away from the hotspot. So the newest islands would be here, and they'd get progressively older as they moved right to left. Also get that in your notes. Now this is how geologists use hotspot volcano chains to track the movement of tectonic plates through time. Write that down. Okay, now that we've looked at hotspots, let's take a look at some more traditional kinds of volcanoes. Now it's worth re-mentioning that a volcano is a place on the Earth's surface where hot, molten rock is we call magma, get that in your notes, where this magma breaks through the surface of the Earth. Very simply, a volcano is a vent or chimney that connects molten rock, magma, from within the Earth's crust to the Earth's surface and includes the surrounding cone of erupted material. Write that down. That's a mouthful. So it's a vent or chimney, just like you see here in this picture. There's a little vent. It's a vent or chimney that connects molten rock, magma, here's the magma down here in a magma chamber, connects that from within the Earth's crust to the Earth's surface, and also includes the surrounding cone of erupted material. So here's your cone right here. Cone is what would stick up and we'd see on the surface of the Earth. A volcano is considered active when two conditions are met. Let's get these conditions in your notes. Number one, it's active if it erupts lava, rock, gas, or ash onto the surface. Write that down. It's also considered active if it shows seismic or earthquake activity. Write that down. Now, a volcano is considered dormant, D-O-R-M-A-N-T, if it hasn't erupted for a long time. Seismologists use if it hasn't erupted for less than 1 million years. But it could, again, one day. Write that down. So it's dormant if it hasn't erupted in a long time, 1 million years, but still could. Now, a volcano is considered extinct if scientists believe it will never erupt again. Yep, get that in your notes. Lastly, copy the diagram that you see here above in your notes and label it correctly. I realize you're not all artists, but do the best you can and label it correctly, because we're going to talk about the basic parts of a volcano and then get the explanations for each in your notes. So get this little diagram in your notes so I can see it when you submit it. All right, let's define some terms on this diagram. We've already said that magma is molten rock beneath the surface of the Earth. You should also add that magma becomes lava when it reaches the surface. That's the difference between the two. A magma chamber is the subterranean, which is another word for underground, cavity containing the gas-rich liquid magma which feeds a volcano. So this is the magma chamber down here, this little area that holds it. Now the word conduit that you see right here. Conduit is a tube-like passage followed up by magma in a volcano. So it's the path that magma takes up to the surface. It's called a conduit. Now, vent. A vent is the opening at the Earth's surface through which volcanic materials, and when we talk about volcanic materials, we're talking about three things: gas, rock, and lava. So the vent is the opening now where that gas, rock, and lava is allowed to get to the surface. You actually see a couple of them there at the top of the diagram. And lastly, the cone. The cone, a volcanic cone is composed of two things. Let's get them in your notes. One, it's composed of loose fragmented material called pyroclastics. Pyroclastics. And or it's composed of lava flows erupted from the vent, where this erupted material builds up with each eruption forming the cone. So make sure you have those terms in your notes. So let's answer the question, how and why volcanoes erupt. The high temperature of the Earth's interior melts the lower crust and mantle and turns it into molten rock we call magma. If you don't have that in your notes, write that down. Now, because it's now a liquid, the magma is less dense than the crust rock. Therefore, it can rise to the surface. Yep, write that down. So the reason that magma rises up through these conduits and vents is because it's a liquid now. And if it's a liquid, it's less dense. If it's less dense, then it's going to float up through the rock. Now, what's the source of the heat that melts the rock? There are four sources we want to get in your notes. Some you know, some you may not. So let's write them down. 1. Heat left over from the cooling of the Earth and solar system when they were formed. So there's still some heat being lost from that original formation of the Earth, and that helps heat this rock. Number 2, radioactive decay of elements found in the mantle and core of the Earth. All elements on the Earth are constantly in a source of decay, and when they do, they give off heat. We'll talk more about radioactive decay a little bit later in this class. Number 3, and of course the main source, is from the convection cells located in the mantle, which brings hot rock up from near the interior of the Earth and returns cooler material toward the center of the Earth. You have that in your notes, but just understand that that's one of the sources of the melting of the rock that flows up through volcanoes. And then lastly, a final source would be the shock or impact melting from meteorites that hit the Earth. Now obviously that's not nearly as common now as it was before, but it's still a source of heat when those meteors were hitting the Earth. So it's good to get that in your notes. Now there are actually two styles of volcanic eruption: explosive and effusive. You see the words here on the slide, effusive and explosive. So get those in your notes. Now, in an explosive eruption, rapidly escaping gas bubbles rip apart the magma into fragments. Write that down. In an effusive eruption, The magma leaks out onto the surface very slowly as lava flows. Yep, get that in your notes as well. Okay, we've already mentioned that effusive eruptions are characterized by the passive or very slow outpouring of lava onto the Earth's surface. Why does this kind of eruption actually happen? Well, it happens for two reasons. Let's get them in your notes. Reason number one, because there's not enough gas, you might hear that referred to as volatiles. There's not enough gas or volatiles in the magma to break it apart when it reaches the surface. Write that down. And the second reason is that the magma is too sticky to allow the volatiles to escape quickly. It's important to remember that molten rock is called magma when it's underneath the ground, and it's called lava once it's been erupted onto the surface. So the second reason is that magma is too sticky to allow the volatiles to escape quickly. So make sure you have those two reasons in your notes. Now there are three basic kinds of volcanoes we want you to know about. The first is called a shield volcano, like you see in this picture above in Hawaii. Now let's write down the four characteristics of a shield volcano. So you have an example I'm going to ask about Mauna Loa in Hawaii, and now we're going to give the characteristics of a shield volcano. Characteristic one, the lava has a low silica level. S-I-L-I-C-A, you've heard us mention that before. It has a low silica level. I should say the magma has a low silica level, which would mean the lava would too. Characteristic two, the magma has a low viscosity. Remember, viscosity is the liquidy part of it. So if it has a low viscosity, it means it's very thick. Three, the eruptions have low to medium explosivity. Low to medium explosivity, which means it's not like Mount St. Helens where it blew the side of a mountain off. Shield volcanoes have very low to medium explosivity. Number four, just like you see here in the picture, the profile of a shield volcano is that of a flattened mound from which it resembles a warrior shield from above. So if you look at the profile of this shield volcano in Hawaii, it's very low, flattened mound, and if you looked over the top of it, it would look like Captain America's shield. So those are the four characteristics of shield volcanoes. Okay, our next type of volcano is called a composite volcano. And a good example is Mount Rainier in Washington, and here's a picture of it you see here in this slide. So composite volcanoes, and there are 6 things we want you to know about composite volcanoes. Let's get them in your notes. 1, magma. The magma in it is very high in silica. Characteristics 2. Magma is very high viscosity, which means it's not thick, it's runny. 3, the magma has very high levels of gas. High levels of gas. Now, because it has a high level of gas, these kind of volcanoes have high explosivity. They're highly explosive. And then if we take a look at the profile of this composite volcano, you see that it's classically cone-shaped. You see this classic volcano cone shape here. Now this cone is formed from layers and layers and layers of lava and ash. Now it's actually got some snow on it too, but if the snow were melted off, you'd see the cone was covered with lava and ash. So those are composite volcanoes. And the third type of volcano is the cinder cone volcano, like you see here, the one in Hawaii. I think it's called Pu'aka Pele. I think that's how you say it. But write it down so you recognize it on a quiz as a cinder cone volcano. Let's get some characteristics of cinder cone volcanoes in your notes. First, the magma has a low silica level. Two, the magma has high levels of gas, so it's fairly explosive. In fact, we call this explosivity the fire fountain effect. It's a fire fountain type eruption. So here's what it looks like when it's not erupting on the left, and when it is, we call these a fire fountain eruption. Fairly explosive because it is a high level of gas. Now, location-wise, they're commonly found on the flanks or very near shield volcanoes. In fact, you can see a shield volcano off here in the distance. So they're often found on the flanks. I guess this is like the plains. The flanks of a shield volcano. And lastly, its profile is made from a pile of rock pieces which make it structurally weak. So you can see it collapsing here in the middle. These little rock pieces are fairly weak. So once they get to a certain point, they collapse right in the middle. So those are the characteristics of cinder cone volcanoes. Okay, that's it. Make sure you take a picture of your notes for this podcast and submit them to Moodle, and then go grab the study guide for this part and get started on the questions. Talk to you soon. Bye.